Hi everybody, Rob Meyer here. Today I'm working on my full-size R2-D2 replica, and I want to demonstrate the new Lifeform scanner assembly that I have installed. I've been working on this for about a year now, and as some of you may have been following in my blog, I had some issues with trying to get the assembly to retract safely into the dome without crashing into the side of it. So I spent quite a bit of time working on a homing system to get that function to work. Initially I had worked on doing that with a purely mechanical system with a series of guides and such like that, but it was not very reliable. It would fail about half the time. I wanted something more reliable, so I tried to develop a smarter system. So we'll give this a quick demonstration, and then we'll get into the details of how I put the system together. So this is all running on the voice control system for my R2, and that's normally how I run the lights and sounds and everything in the dome here. So it is responding to the voice control system, and I have the Lifeform scanner set up to respond to the voice control system as well. So that we do have a voice command that activates that, and I'll show you that when it happens. So we'll give a quick test here of the voice command to make sure that R2 is responsive. Hey R2. Hey R2. Light beam. And that shows us that he is listening. You notice the first time it didn't work. Sometimes he's in the middle of a cycle and he's not ready to listen to his trigger phrase. That essentially happens every time you see this PSI indicator flash. There's a pause there in the program that he's not actually listening to the trigger phrase. And in that way, we actually are able to use the PSI indicator to, that's my way of confirming that the system is looping through the program properly. So let me turn off this light again real quick. Hey R2. Hey R2. Light beam. Okay, now we'll do the command that activates the Lifeform scanner. Hey R2. R2. Where's Luke? So that command for activating the Lifeform scanner is "Where's Luke?", which you might remember from The Empire Strikes Back, where R2 is standing outside the hangar and they need to close the doors, and Luke is somewhere out there on the frozen wastelands of Hoth, and R2 is scanning for him. So I thought that was an appropriate voice command to use there. So I'm going to do one more test of the system, and this time I'm going to when we're finished, I'll open the pipe panel door back up and grab the camera and show you a quick look at what's inside there. And then we'll go to a closer up view of the scanner head itself and talk a little about the homing system. So one more quick test. Hey R2. R2. Where's Luke? You notice I have it retracting really slowly back into the dome, and part of that is because of the homing function, and we'll discuss that a little more too. So let's take a closer look and see if we can see what's going on down inside the pipe panel opening. So it's kind of hard to see on this close-up view with my GoPro because it doesn't focus very clearly at this close range, but essentially there's a pair of infrared LEDs right here that are aiming at the panel in the Lifeform scanner head as it lowers down into the dome. And the electronics on the LED board of the scanner head are able to pick up these pulses of light coming off of these infrared LEDs, and it can then determine whether it's pointing to the left or to the right. You can see here that the surrounding face of the pipe panel opening is very closely trimmed. I took off every bit of material I could because I wanted the most most space available for the head to retract back in there, especially on the bottom edge here where the edges of the screen come in contact, and the back edge here where where the antenna mast and the coiled cord basically ride against that on both extend and retract. So this Lifeform scanner head is mounted on a magnetic base, which makes it really easy to pull it out of there to work on it. I can just reach in here and pull it loose and lift it out, and if you'll watch, it'll activate there. And the reason it's activating now is because it's a magnet that keeps it deactivated. Essentially, and we'll get a better close-up view of this, but there is a magnetic reed switch in the middle of this panel here, which actually turns the power on and off, and it corresponds to this rare earth magnet that I have mounted right here in the compartment. And if you look down in there, you may be able to see the base of the mast down there, and down inside that hole is another rare earth magnet that corresponds to this one here, and that's what holds the scanner head down on the mast. So we'll go ahead to a close-up view of the scanner head and talk a little bit more about the homing system. At the bottom here, I don't want to keep the laser on these very long, but right there and right there are your left and right infrared sensors. And those are what reads the homing beacon from that pie panel that I showed you, the two infrared LEDs there. And then in the center here, you see this white styrene plastic. And those are actually the baffles that block. And from this camera angle, we can kind of get an idea of how that homing would work. Let's say the antenna is retracting into the dome, and it's a little pointing to the left like that. You see where eventually that baffle is blocking that left side sensor there. And at the same time, this baffle is showing the left side sensor. It's not only showing it to the infrared LED coming off the pie panel, but I also coated the inside edges of these baffles with aluminum duct tape to actually give it some reflection, so that if the head were way off to the side like that, it would still be reflecting the light from that IR LED right back onto the sensor, telling it to pull itself back over this way. And you see is that the minute it gets back into this range, it's going to expose this left side sensor again and stop rotating. There is some lag time there, and I just took a little work in the programming and testing to figure out how much lag time I would allow before the system comes to a rest, and I actually allow for a little for it to overshoot it a little. And that's why when you watch, I hope I can record a slow motion, or maybe capture a piece of slow motion off of the previous test video we just did. But as it is retracting, when it gets close to the pie panel, you will see it oscillating back and forth like this as it finds its way back home. And that's basically everything that's going on in the scanner head. What I'm going to do now is I'm going to pull this rare earth magnet off of here, take it out of the influence of that reed switch, just to show you how the system will activate and go through its cycle. If I can get it to come loose from that determined terminal there, that steel terminal really has an affinity for it. Okay, we should see it activate here in a second. And that's the normal timing of it. I have some details of the homing system. Take a look at the board here. First, we have the 40 milliamp hour LiPo battery that's hiding behind the board. So you can't see it here, but it's thin enough that it's actually tucked away between the board and the antenna screen. And this here is the charging port, which is basically a copy of the same port that's on the Estes Proto X micro drone. The charger for that drone just happens to work well with this battery, so I copied the charging port over onto that. Here we have the JST connector for that LiPo battery, and someday when I clean the board up, I'll probably remove that connector, solder those wires directly to the board, and I'll be able to hide that red and black wire behind the board so it won't be visible there. And these are your two plain old white LEDs, and nothing really special about them. These are the screw connectors for the motor leads. I needed a convenient way to get the leads on and off the board as I was working on it. And these are just a regular 2.5 millimeter JP series screw terminals that I stripped the plastic insulation off of. Then I made pads on the board and soldered them directly to the board. This is the 3-pin pickaxe programming port. It's just a standard 3-pin header, 1/10 of an inch spacing. This is the pickaxe 08M2 SMD microcontroller. It handles all the logic, the timing of all the functions, the inputs to the motor driver, and reading the IR LEDs. This is the DRV8838 motor controller. I chose it because it's got a small form factor, handles all the functions for driving the motor with just 2 inputs, which is compatible with the pickaxe microcontroller I'm using. There's just one input for motor speed and the other one for direction. And these are the 2 infrared detectors, and we talked about those earlier, but here you see them angled slightly down on the board. And this is the baffle in the center, which again, we talked about it a little earlier. It blocks the light between the 2 detectors and also reflects the light back on the detector from the side. And finally, this is the magnetic reed switch that powers the board on and off. This is a single pole double throw reed switch. We're only using the normally closed position such that whenever the board is within the influence of the magnet inside the pie panel compartment, it is basically off, the contacts are open, and then once the antenna mast extends and the scanner head clears the pie panel opening, the contacts close and the board is able to complete the scanning cycle. Okay, so now we're back from our discussion of the details of our scanner head here, and I'm going to show you one way that I can reinstall the scanner head back into the dome. So you might have saw the LEDs just on this. I had pulled the little magnet back off of the board that I had holding the reed switch open, and so the scanner head just finished completing a cycle there, and it's now basically on in an idle state waiting for its next cycle. So what I'm going to do is go ahead and issue the Lifeform scanner command like I did before to bring the mast up out of the dome, and again with the magnetic base I can just pop this back on, and at which time it'll eventually retract back into the dome like the normal cycle. The only difference is this time, because this has already completed its cycle, whenever I reinstall it in the dome this way, I will have to be ready to guide the antenna back into the dome because it's not currently still in its homing mode like it would be in a normal cycle. That mode basically lasts for about 10 seconds after the motor scans, and then it just goes into an idle waiting mode to conserve the battery. So I'll go ahead and install it, and then we're going to attempt to do one more cycle of the system. So for now we'll go ahead and install it back into place. Hey R2, where's Luke? There's a mast, and it's just plugs right back in like that. That's all there is to it. And it's actually pretty close to going in on its own. There you go. That just happened to line up perfectly. Wouldn't it be nice if it could have worked out like that every time? So again, there was no active homing going in there. That just happened to line up just right as it went back in. But now the system is ready to be active again. If I were to deploy it again, it would go through a normal cycle. Well, what the heck? Why don't we just do it and find out? Hey R2. Where's Luke? Okay, now we're back home. So, and I think that'll conclude this demonstration. Because this video is starting to run pretty long, so I think we're going to leave this at that, and I'll probably record a second video where it's just exclusively a close-up shot. I think I want to do some experimentation, and just for my own fascination, I'm curious to see if I might actually be able to visually see the infrared homing's signal being picked up on a different, like a CMOS camera or something that might be sensitive to infrared wavelengths. I'll do that for a different video, and for now we'll just call this video finished, and I hope you like what I did here, and just if you have any questions you can post them on the astromech.net website or on the YouTube comments. Thank you.